My name is Leah, and I've been with First Programs for 8 years. My first 5 years were with First Lego League, and the last three have been mentoring the First Tech Challenge team. Um, and it started as another team name, but it's now known as Robot Legion. And then I'll let Jessica go ahead.
Hi, I'm Jessica Steimel. I've been coaching this FTC team for 3 years now. Before that, I coached my son's FLL team for a year. Now on to Rick.
Hi, I'm Rick. I've been with First at DRSS for 4 years now. This is my first year mentoring for an FTC team, but I coached FLL for 3 seasons prior to this year. And I'll turn it over to Dwayne.
I'm Dwayne Egbert. This is my first year as an FTC mentor. Robot Legion is not a new team, but it has a mix of new and experienced members, with the most senior member having been on the team 3 years. We are one team made up of 3 functions, which are engineering, software, and business. No one function is more important than the other. This one team reads the requirements and decides together on the approach to take. To help manage the project, the team has adopted the Scrum framework, which has 3 pillars: transparency, inspection, and adaptation. With this approach, the team uses a Scrum board to add tasks and track backlog, which is a list of tasks that need to be done, a doing, which is a prioritized list of tasks currently being worked on, and a done, which is a list of tasks complete and validated. Each function takes ownership of their part in the backlog, prioritizes which work to complete first, and performs the work and validates the work is complete. Practices start with a 10-minute team meeting around the Scrum board discussing priorities, and they break up into functions and then come together at the end of the practice to discuss accomplishments, raise awareness to tasks needing extra help, and make sure all functions are synchronized. During this time of social distancing, the team has incorporated the Trello application, which may be continued once practices can be held in person. Next, Rick will talk about robot design.
Okay, thanks. I have a short presentation to go over. All right, can you see that okay?
Yep.
Yes, I can see it.
Okay, great. So I'm going to be talking about robot design and game strategy. So every year there's a new game for FTC, and this year it was called Skystone. First puts out a instructions for the game, and we used that those instructions to come up with a game strategy and then figure out how we wanted to design the robot to fit that game strategy. So the picture over here on the right is the field for this season. And the basics of this year's game is for the robot to take these stones that are on the loading zone side of the field, drive underneath a bridge, and place the stone in a foundation, and then stack stones as high as possible. So there's also 2 parts to the game. It's a 2.5-minute round. The first part of the round is for autonomous action from the robot. And during that time, the robot performs actions all by itself with no interaction from any humans. So the other part of the round is teleop, and we control the robot with like a video game controller. And so it acts more like a remote control robot. So during autonomous, we decided that we wanted to have the robot come over to the foundation, move it over into the triangle here in the corner, and then the robot would come back and park underneath the bridge. And in doing so, we would earn so many points. For teleop, we would then grab stones from the loading zone, travel underneath the bridge, and place them on the foundation and stack them as high as possible. So knowing those actions, we then decided to design the robot with these following features. We thought using Omni wheels and a holonomic drive system would be ideal for easy maneuverability, and I'll explain that a little bit later. We needed a way to pick up the stones, so we designed a claw to pick up the stones. But then once we pick up the stones, we needed to have some way to raise the stone in order to stack them. So we used a linear slide system to do that. All right, so here's a picture of our robot. On the left shows the drive system and how the motors are arranged and the Omni wheels. You can actually get a better view of the Omni wheel on this side. The Omni wheel has rollers on it that allow the wheel to move parallel to the axis of the wheel. So it's a lot more maneuverable rather than just, like a tire on a bike. It can actually move in more ways than one. So the programmers are able to program the motors to turn counterclockwise and clockwise in a way to move the robot forward, backward, side to side, diagonally, without changing the direction of the robot. And so that gives us about the most maneuverable system that we could have. All right. And so just for knowing, the motors that we used on the drive system were Andy Mark 60-to-1 gear ratio. On the top side of the robot, we have all of our features used to control the robot and pick up stones. So we have a claw system, which uses a rack and pinion gear system to open and close, and it has an Andy Mark 60-to-1 motor that controls that action. We have some grippy blue sticky stuff that's not shown here, which helps us to pick up the stones. The claw raises and lowers using this linear slide, and that's actuated using rev side motors shown here. And then we have the rev hub connected to the battery, the phone, and a switch, and then to all of the motors. And the rev hub just acts as a controller, sending the signals to what is necessary to perform the function that we need. One item that's not shown here that I'll speak about in the next slide is a dual intake spool. It's essentially just like a spool of thread that is connected to the linear slide that allows it to raise and lower. Okay, so results of the design and the game strategy. So the blue sticky stuff we found was great at helping us grip the plastic stone, but unfortunately it gets dirty. So we had to keep it clean. We had to clean it regularly. And if we did that, then we really had no issues picking up the stones as long as it was clean. Our initial use of the spool only raised the linear slide and the claw. We found that we needed to hook up the linear slide to both sides of the dual spool intake so that when we raised the linear slide and we needed to lower it, we would have some reliable method to pull it back down. So once we figured that out, we had a pretty reliable system for raising and lowering the claw. So in the end, we were able to deliver 7 stones and stack 3 of them high. And the final takeaway here is that just in practice and competitions, we found that we were better at delivering stones while our alliance partners were better at stacking them. So at competition, we were able to deliver stones while our alliance partner could stack them. And so that was a more efficient way of teamwork. And so in doing so, we were chosen as an alliance partner for semifinals at a competition. All right, that's what I have for the robot design game strategy, and I'll turn it over to Jessica.
As the programming coach, I worked with the programmers to implement the holonomic drive on our robot this year. For teleop, we were able to implement a 2-controller system where one person controls the movement of the robot on the field and the other controls the attachments such as the linear slide and the claw. We also focused on improving our autonomous programming skills this year. We were able to successfully write 4 autonomous programs this season, which are run based on our starting position on the field. From the red and the or blue alliance loading zones, we were able to successfully pick up the stone closest to us, deliver it to the build zone, and then park under the sky bridge. From either build zone, we were able to move the foundation to the building site in the corner and then park under the sky bridge. We have about a 50% success rate with a maximum point value of 20 points, but continue to adjust our program throughout the season to improve those statistics. We have also improved our programming skills, which allowed us to implement a delayed start to our autonomous parking when requested by the alliance partner during a competition. And now on to Leah about our business efforts.
So we connected with several businesses for technical and project management experience. We've heard from a Belcan employee that taught us how to CAD with Autodesk Inventor and how to run stress analysis in Autodesk Inventor. We learned a lot from him, and we could probably CAD our robot with minimal help now. One of our biggest struggles this year was knowing what needed to be done and who needed to be working on it. We had a Scrum Master from Navistar, and you heard from him. He taught us how to create a Scrum board. He continues to monitor our Scrum board and ensure that we stay on task. Our financial sponsors this year included Navistar, GDI, and Wilmington Family Dental. This year we created a promote video. We didn't realize we made the video too long to submit, but that's okay because we will go ahead and use that for future outreach events. This year, our outreach events included Hamvention, a 4-day amateur radio convention that draws nearly 20,000 people from around the globe. We went to 3 family days at the United States Museum of the U.S. Air Force. We attended Tech Fest. It's a STEM-focused program, STEM-focused 2-day festival at Sinclair Community College that provides fun, hands-on activities for families. We demonstrated our robot at the Ohio First Lego League State Championship and the first robotics competition. Those are both at the Nutter Center. And we mentored a First Lego League team at our school this year. Total, we've spent about 30 hours as a team on outreach. We've also highlighted a few spots in our engineering journal that we would like you to take a look at as well. This year we learned a lot, and I just want to highlight those things. Dwayne, how about if you start with the first one?
We learned how to develop a timeline to meet our goals.
We also used CAD to assemble our robot in Autodesk Inventor.
We learned more about Gracious professionalism by driving with DRSS Enterprise. That's the team that we share our workspace with. We also learned why the rules are important and why it's important to understand them.
We learned how to program effective teleop.
We learned more effective engineering design techniques using Tetrix parts.
We learned why practicing for competition is important.
We learned to prepare for our competitions.
We also learned how to implement Scrum this year. Most of all, we learned how to be a team.